Let's talk about the last type of partial fractions, which is called as type 4 improper fractions. And in this episode, we'll just do a quick intro and get some perspective and background on how should we think about improper fractions, and let's try to wrap our heads around that. And in the next couple of episodes or so, we'll solve an actual problem and applying the learnings that we have on this episode. So let's get started on this one. So what are improper fractions? Let's do a quick recap. We already covered this in detail in a different episode, but let me just give a quick shout at what is the improper fraction in this episode, and we'll get started. So improper fraction in the context of partial fraction, whenever we have a rational expression, which is nothing but the ratio of polynomials in numerator and denominator. So whenever you have this kind of expressions, if you see the first three types where we had proper fractions, the degree of the numerator was always less than the degree of the denominator, okay, and hence they were called as proper fraction. And what are improper fractions? It's the exact opposite. Whenever you have the degree of the numerator, it can be either greater or equal to the denominator, then we get something called as improper fraction, and that's the simple definition. So if you see this example, which is what we will solve in the next episode or so, the degree of the numerator is 4 and the degree of the denominator for x is 3 and 4 is greater than 3, and hence this becomes an improper fraction. And we have done that, okay? So we are good so far on that one. And in that same episode, if you check out, I also was explaining using the concept of the number systems, what does a proper and improper fraction mean in the world of numbers, and then we applied the same thing to the context of polynomials. In the world of numbers, if the numerator is bigger than the denominator, in this case 9 is the numerator and denominator is 5, and 9 is bigger than 5 or greater than 5, then we call this as an improper fraction. This is in the world of the number system. And in the world of polynomials, it's the same concept, because we are going to have polynomials. So instead of the whole numbers, we will just talk about the degrees or the powers of the unknown variable x, if it's just one variable. So we'll take the powers of x in the numerator and compare against the denominator. So that's the only difference. Otherwise, the concept of the definition of something in the numerator being bigger than something in the denominator remains the same, and that's what we call as a improper fraction in the world of numbers. So for the next few minutes, we are going to just rehash and recap some of the things that we understand in the world of numbers, and we will notice that it's interesting that exact same thing applies to the world of polynomials, and hence this is very easy to start from here and then apply it to the partial fractions. So if you see here, I've copied this visual from the other episode where I was talking about proper and improper fractions. In the same episode, you would have seen that I have borrowed this visual from the Google. And if you focus on these two things, right? So we have a improper fraction 9/5, which is where 9 is larger than numerator is bigger than the denominator. And then we have something called as mixed fraction, okay? Although these are not related in this for the same numbers, let's understand what is the relation between an improper fraction and a mixed fraction. Not in this context of this number, these are just examples, but in general, how can we convert an improper fraction into a mixed fraction, and how can we convert a mixed fraction to an improper fraction, and what exactly is a mixed fraction? Let's try to understand. And these things we had already done in elementary school using our primary school maths. And we always wondered, whatever we learn, where the heck are we going to apply that? So finally, somewhere it's coming handy. So this should be grateful that we can apply those learnings and put them to use today. So let's focus on just the mixed fraction, okay? So I put the definition here, but let's come to that in a second. So let's say we are going to convert a mixed fraction into a improper fraction. We're going to start from here, a number something like this, and end with something like this. Let's see what's happening there. So if let's say you're going to order pizza and you say your friend is asking you how many pizzas you want, you say that I'm going to eat 2 and 1/4. I'm going to eat 2 whole pizza, whatever size that is, and I'm also going to eat 1/4, which is almost 20, not almost, like 25% of the third pizza also. If you see, if I take the whole pizza and if I divide it by into 4 pieces, I'm going to eat this piece also, whatever is in green. So I'm going to eat this, I'm going to eat this, and I'm going to eat this also, okay? And rest, I don't care, you can give. So that's what this mixed fractions means in 2 and 1/4. So it is as good as saying that I'm going to consume 2 plus 1/4, right? That's what I put here. So although you express in this format, it's not multiplication, it's an algebraic addition. It's 2 and 1/4 in the mixed format in the mixed format, basically algebraically means you're just adding these two numbers, 2 plus 1 by 4. That's what I'm going to consume. That's what it means. And when you do the arithmetic or the maths, it's basically just cross multiplication and taking the common LCM, which is what it is, 2 into 4 and then plus 1 and over 4. And once you do the maths here, you get 9 over 4, which is nothing but an improper fraction because the numerator is bigger or greater than the denominator. So that's how you start from an improper fraction. And I've explained you the context of what it means in terms of this. We know that it's an addition. And once you do the maths, we can convert that into an improper fraction, which is this case. Okay, that's what it means. So, and likewise, if you take another example, let's say I want to eat 2 1/3 of a pizza. So I am going to eat 2 pizzas completely. And instead of the 1/4, instead of 25%, I'm going to roughly eat 33%, 1/3 of the remaining pizza. So that the whole remaining pizza I divide into 3 sections and I'm going to just eat this. The same concept, and then you apply the same thing, then you get an improper fraction. So 2 1/3, that is 2 plus 1/3 if you add, and if you do the same maths like I explained, you get this 7 over 3, which is an improper fraction. Again, if you see here, numerator is greater than denominator, 7 is greater than 3 over here. Okay. So I put some more examples, but you can just, you get the drift where I'm going with that. So what do we see here? Once we are trying to convert those improper fractions, once we are trying to convert a given mixed fraction into an improper fraction, what do we notice? There is a relation between them, and the relation is a mixed fraction of this sort. Let's say 2 1/4, 2 1/4. This is a mixed fraction, and then we have 9 by 4 over here, right? If we have 9 by 4 over here. So what we notice is whenever we have an improper fraction, or like 9 by 4, and when we try to express it like this, okay, so what it means is a mixed fraction is nothing but an improper fraction, but which is kind of put in this format where you have a whole number and you have a fraction, which is a proper fraction. If you see this piece is not an improper fraction, it is just a proper fraction because the degree of the numerator is less than the denominator. In this case, we cannot talk degree because we are still talking about the number system, but the number in the numerator is 1, number in the denominator is 4, and 1 is less than 4. Similarly, if you see here, the number in the denominator is, this one, hold on. Okay, if you see here, just this portion, the number of the numerator is 1, the number of the denominator is 3, and 1 is less than 3. So this part is a proper fraction, proper partial fraction you can call. So what in essence is a mixed fraction is nothing but a combination. It is essentially an improper fraction, but the way it is expressed is you have two parts to that. One is a whole number, and then you add a proper fraction to that. That's what it is. That's what we do here. We have a whole number 2 and we add a proper fraction to that. We have a whole number 2 again here and we add an improper fraction for that. Again, in this case, we have a whole number 3 and then, in this case also we add proper fraction, improper, typo, slip of my tongue. So in this case also we have a whole number and we add a proper fraction, proper partial fraction to that. So that's a relationship between a improper fraction and a mixed fraction, as simple as that. So again, repeating, mixed fraction is nothing but an improper fraction, but which is expressed in two parts where we add a whole number to a proper fraction, and that's it. Okay, if you just remember that, we'll apply this to the polynomials. And just as a quick reminder, this visual helps. So there's a whole number in mixed fraction, there's a partial fraction, proper fraction, and it's a plus. Okay, it's not this one, it's not multiplication, although it looks like when you put them together it looks like multiplication, but it's a plus. Remember that, and I explained you that. Okay, now we have done that. Okay, now what does it do to our polynomials or in the context of what we need? Okay, now let's try to do the opposite. Now we have understood what is a mixed fraction, and from there we have come to the improper fraction. So we started from a mixed fraction over here. We started from a mixed fraction and we came to this. Now let's try to do the opposite, which is what is more interesting and which is what we can borrow when we kind of compute the polynomials in the context of improper fractions. Okay. All right. So let's do the opposite. We are going to start with an improper fraction and we are going to convert them into mixed fraction. And how do we do that? Again, the same concept we did in basic or elementary maths, where we do something called as long division. This is called as long division or we can also call this as synthetic division. In some textbook it's called as synthetic division, basically where you are where we will be doing you will be solving the improper fraction and you will be converting that into mixed fraction. Let's try to understand that, and this exact thing you'll be applying for the polynomials. So if you pay attention to this and if you get this, you got the polynomials also. Okay, let's take an improper fraction where the numerator is bigger than the denominator. So we have 10 by 3, and we know that whatever is in the bracket inside, this is going to be dividend, or the numerator is the dividend, and whatever is outside, which we are trying to use it in the denominator, is going to be divisor. Okay, and I put it here. If you see, use the visual. So once you start dividing it, we know that 3 times 3 is 9, and then the remainder is 1. And now this remainder is become less than the divisor, which is 3, less than the divisor, which is 3. So we cannot divide it anymore. So whenever we get a remainder where we cannot divide it anymore, we just stop the process. Okay, we just stop the process, and from that point onwards we just try to get the mixed fraction for this improper fraction. And what is this? We have 3 and 1/3. And what does it mean? If you see here, if you don't know the terms, here I put what is a divisor, what is a quotient, what is the remainder, and what is the dividend. Okay, so what have we done exactly? Okay, so if you see here, if I just use the numbers in different orders, we have got a mixed fraction 3 and 1/3. Okay, and what does that mean? We know that whenever we give a mixed fraction, we have to just add the whole number to the partial fraction, the proper one. That's what it means. And once we do the multiplication this way, we get all the way here, and the number that we get is 10 over 3. Okay, so we get 10 over 3, which is what was given to us. So that way we have converted a given improper fraction into a mixed fraction. And what does that mean actually? Let's try to understand here. So if you see, we would have done this a zillion times in the elementary maths, where you take this example. Let's say I'm going to take this example over here. Okay, so we have 10, I'm dividing by 3. 3 times 3 is 9, and the remainder is 1. So what this expression tells, if I can use this kind of a formula or this kind of formation to express this. So my dividend is equal to, dividend is this piece, is equal to divisor, this and this multiplied. This 3 and this 3 multiplied. This is the divisor and this is the quotient. And if I add the remainder, this is what I get. So 10 is equal to 3 into 3 plus 1, which is 10, which is what you get here also. If you take this, I've highlighted I've just color coded so that you can understand. Green into red plus blue is equal to black. So 10 is equal to 3 times 3 plus 1. Okay. This is the easy formula that we already know. And if you kind of slightly tweak this formula, for example, if I divide in this formula, divide both the sides by the divisor. Okay. This is what the formula will look like. So dividend over divisor is this. If I add this over the divisor and divisor gets cancelled. All will be remaining is the quotient over here, and plus remainder over the divisor is what this is. Okay, so if I do that, this whole expression becomes 10 over 3. Okay, 10 over 3 the divisor, and this is nothing but the improper partial fraction that we had received in the given problem. So this is what 10 over 3 is. 10 over 3 is equal to, what is the quotient? The quotient is nothing but something in red color, which is 3, plus the remainder is 1. We know that in blue color, divided by the divisor is again 3, which is in green color. So that way, and whenever we express this mixed fractions, if I remove the plus sign, I can also use this mixed fraction notation to express that. So in essence, what have we done? We have taken a improper fraction in the world of numbers where the numerator is greater than the denominator, and we have applied this particular formula which was extracted from here in terms of long division, and we have converted that improper fraction into a mixed fraction, which is nothing but a combination of a whole number plus a proper fraction. Okay, so far with me, that's what we have done. And that's exactly what we will do when we solve rational expressions in polynomials, where we will take the equivalent of this. In a polynomial world, we will not get 10 by 3. You might get something like this example in x, where if you see x to the power 4 divided by x to the power 3 plus 1. we will take something of that sort. We will apply the long division, which I'll show our demo in the next video. We'll apply the long division or synthetic division, and we'll convert that in a way into a mixed fraction polynomial instead of numbers. And what does that mean? We'll convert that into a whole polynomial plus a proper fraction polynomial. And once you get this, in this case, by the time you get this, the degree of the numerator is going to be less than the denominator. And then we can solve just this piece all by itself using any of the first three types that we know. We can use type 1, type 2 or type 3 based on how the denominator is spanned. Now, because it has become a proper fraction, so we can apply the first three types and then solve that problem. That's the whole concept of solving an improper fraction. So first, somehow you convert that improper fraction into a proper fraction along with the whole polynomial, which is nothing but a mixed polynomial kind of a concept, and just take the proper partial fraction and solve it using any one of the three types that we know. So just like one step we need to do extra, and then the remaining steps are the same, whatever we have seen in the previous episode. So that's all for this video that we have, how to solve a improper partial fraction like this. And in the next episode, I'll show you a quick demo of how to do the polynomial division that we have learned. We'll do a quick refresher, and they will straight away jump into problem solving of how to exactly execute this. We'll take this exact problem and try to solve that and resolve that into a partial fraction.